All right, let's look at the linear approximation problem in chapter 14, section 4. We have seen this kind of problems in single variable calculus. And here is just an extension. And let's first look at the theory, what it means. Okay, suppose you have a function, z is equal to f of x, y, okay? And imagine your function's graph looks like this, okay, like this, okay? And this is your z-axis, and here you have y-axis and x-axis. And here you have a point in the xy plane, that's x naught, y naught. Okay? So you have a value over here, and let's call this value z naught. So this value over here is f of x naught, y naught, which is equal to z naught, okay? And then we know if you have a good surface, if derivatives, partial derivatives exist and are continuous, then you can have a tangent plane over here, okay? This is a tangent plane. And then we know that near this point, your tangent plane can be used to approximate the surface. And that's where this formula is from. If we look at the equation of the tangent plane, that's exactly what we have on the right-hand side. Okay. So this plane over here is LXY. C is equal to LXY. All right. And also we have the formula so-called total differential, and that's the one we have over here called dz. What it means is that when both x and y are changing, then if you want to find the approximate change in the dependent variable z, then you have this formula. Okay. And recall in single variable calculus, we had something like this. dy is equal to f of x dx, right? Now it's two dimension, so we have two terms. So let's look at an example over here, how to do this. Once we have understood where the formula is from, we can simply plug in the formula with the necessary data over there, then we have it. So let's look at the solution. First, we are asked to find the tangent plane of the surface. And we know to find that, we know the equation, we need to find the derivatives, right? And then we say partial derivative f of x is going to be 2x and plus y. And if this partial derivative at 0.11 is equal to 2 plus 1, and that's going to be 3. Let's look at the second partial derivative, and that's going to be x plus 6y, right? When we take the partial derivative with respect to y. And then fy at 1, 1 is going to be 1 plus 6, and that's going to be 7, okay? So now we have the tangent lines equation. So, not tangent line, the tangent plane. Tangent plane equation. We have z minus z naught, which is 5, is equal to derivative at this point, fx is 3, and then we have x minus 1 and plus 7y minus 1, because we have 1, 1 over there. So that's the tangent plane's equation. And if we want to write the equation in a standard form, we can do a little bit of computation. So z minus 5 is equal to 3x minus 3 plus 7y minus 7. So what it means is that 3x plus 7y minus z is equal to, we see we have negative 10 on the right hand side and negative 5 on the other side. So we have is equal to 5. Okay. All right, so that's the tangent plane's equation. Okay, that's the first part. Let's mark it over here. Second part, we want to find the linear approximation. What it means is that we have f of xy, right? And that's x squared plus xy plus 3y squared. This is approximately, we just take the right hand side. It's approximately 5. That's f of xy at the point 1, 1. And then plus 3x minus 1 plus 7y minus 1. Okay, we see where this is from. Just add 5 both sides, right? And then this is going to be 3x plus 7y and minus 5. Okay. So that's approximately true. So what it means is that when xy is approximately 1, 1, this f of xy is approximately 3x plus 7y and minus 5. Okay, now let's try to see if we can apply this linear approximation to find the value, approximate value of f at point 1.1 and 0.98. Okay. So it's actually easier to use the first formula, so number 3. So we have f 1.1 and 0.98. This is approximately 5 plus 3. X over here, this is x, this is y. X minus x naught, 1.1 minus 1, and plus 7 and 0.98 minus 1. Okay, and that's going to be 5 over here plus 0.3 and plus 7 times 0.02. So we can actually finish this computation. It's 5 plus 0.3 and it's minus, okay, and minus 0.14. So we have 5 plus 0.16 over here, right? And that's equal to 5.16. All right, and we remember the value at 1, 1 is 5, and value at 1.1, 0.98 is approximately 5.16, and that makes perfect sense.